Back to atoms, doing it again. Okay, so you may have learned back in chemistry that we once thought atoms were made up of plum pudding. Or maybe it was the plum pudding model, and plum pudding is just something you eat. I don't know. But we had this idea of plum pudding models where atoms themselves were like solid. There was this, stuff, whatever it was, and then inside of it, there were tiny little particles. So there's like all these particles are embedded in stuff. So they named it plum pudding because these are like plums in your pudding. Sometimes you hear this as a cookie model, but whatever. We learned that this was wrong. We did a gold foil experiment where we set up a detector in like a nice semicircle and we beamed into it alpha particles, which is really nothing more than helium. And these alpha particles were trying to strike a gold foil. Well, the interesting thing is that most of the alpha particles passed through the gold foil and just hit the back of the detector. But some of them bounced at like random ways. Okay? Now, this is really weird because if this is like a solid plum pudding, then they should all bounce. But we saw a bulk of them just pass straight through. And this means that atoms were made up of pretty much nothing. They are made up of mainly empty space. And because of that, the next thing that you'll learn in your chemistry courses is this idea. The fact that if atoms are mostly empty space, we like to think of them like this. In the center, there's a positively charged nucleus, which is made up of our neutrons and protons. And then around it, we have our electrons, like this. Now, to give you an idea of sizes here, these are really small sizes. We're talking about like the size of a nucleus is on the order of like 10 to the minus 15 meters, and the size of like this electron setup is something like 10 to the negative 10 meters. So this is all like really small stuff we're dealing with, but it's mainly empty space. Now, when we learned about this in chemistries, this was like a nice model of the atom. But we technically call this a nuclear or a planetary model of the atom. Because when you originally learn about this, you're told that these electrons are orbiting the nucleus. That's wrong. The electrons don't orbit the nucleus like a planet orbits the sun. That's not a thing. You learn a little bit later in chemistry that instead of these planetary orbits, what we actually have is like an electron cloud, where we have a central nucleus, and then for your s electrons, there's a sphere around it, and the electron is just found in that sphere. And for your p orbitals, there's a central nucleus, and we kind of get this like weird figure 8 shape that runs through it. And for our d orbitals, we kind of get this weird like pyramid where it's like the back end, which is kind of hard to draw. And as you get like higher and higher orbitals, these shapes get totally weird. And these shapes are actually determined entirely via quantum mechanics, which we're not getting into because this is an AP Physics 2 video. But if you're interested in that, it's a whole quantum mechanical process and where forbidden regions are due to certain equations. Okay? So, why are we actually caring about this? Because it's wrong. This planetary model is wrong, but it will give us some interesting ideas later on. One of the reasons that we know this idea is completely wrong, though, is the following. If this electron were to be orbiting this nucleus, then that means that this electron is technically accelerating. Because this electron is going in circular motion, it has to feel a centripetal acceleration. And if it's feeling a centripetal acceleration to stay in this orbital path, there's the acceleration there. Well, it turns out that if you have an electron that is accelerating, it should be giving off some amount of light. It should be luminous. And this is a really weird idea because if this electron was giving off light, then that means by the equation, E equals h nu, Planck's constant, times the frequency of that light, that electron is giving off some energy. And if that electron is giving off some energy, that means the electron is losing energy over time. And over time, this would mean that our electron, which started in a nice circle, would lose energy and wind up in the nucleus, which we definitely don't see. You're not glowing in a rainbow pattern, and then your body's not collapsing down onto itself into all of your nucleus. We don't see that. So because of this, we know that this planetary model is wrong, but we're still going to come back to it, and we still teach it because it does some neat things, and it brings some interesting ideas to the forefront. But the actual orbital clouds, that's what we really care about in the world of quantum mechanics. Okay? Now, because this planetary model is wrong, and we do see our clouds here, the question becomes, what is happening with our electrons as they do give off light, as they kind of change energy levels? What's going on there? What's going on with this idea that you may have learned about of having different orbital shells? And what we're going to talk about in a later video is we're going to talk about line emission and line absorption spectra. And we're going to talk about why it is that we see light in certain ways and what is going on with electrons as they become energized from different photons striking them. But for now, this is finished. Don't go collapsing in on yourself. And until next time, adios, and take it easy.